And I took this picture where it actually is showing the ball going up, middle, down, middle, up, middle, down. And then what is happening on the x-axis is time. On the y-axis is distance. So we have time rather than just angles for these. We have time. And then it says, from the spring, you can conclude that the period, the time for one cycle, it said it up here, but I skipped over it. It said that the ball goes from its maximum displacement down to its maximum negative displacement, all the way back up to its maximum positive displacement, and it takes 4 total seconds. So that 4 total seconds that it takes for the ball to go from here to here to here again, that would be the period. So down here it says the period is 4 seconds, whoopsies, and then the amplitude is 10 centimeters, because that's the displacement that it goes above and beyond that, above and below that middle line. And then this motion happens in nature. Just going to skip ahead because this one has, that's the ball question. I'm just going to skip ahead just for a second. You guys can see if we dropped a rock into the water, how the water ripples. And this problem, if we get to it, I didn't get to it in my other class. If we get to this one, if there's a little, what are those things you use for fishing that floats? What are those called? The bobber? Am I saying it right? It says it in here somewhere. What's it called? A bob. It's called a bob. Anyway, it's because this bob goes down and up and down and up and down. And there's the graph of the bob going down and up over time. Over time. So at a different time period, it's up, where at a different time period, it's down. So this kind of thing does happen in real life. Here are the equations for simple harmonic motion. We have a sine equation, we have a cosine equation. They look pretty much the same. In this equation, the d, I've already told you the d is the distance. That's the y value, but it's the distance. And the t is time. And then when we were doing transformations before, we would have this b value that would always affect the period. In this equation, the b value is an omega. And we can get the omega if we know the period. If we know the period, we can find the omega. So the period is, like for that first one, it was 4. And if I set that equal to 2 pi over omega, I can solve for omega. I'm just going to cross multiply that. So for that first example that we were talking through with the ball, this omega value is pi over 2. So if you were using that, that would be like the horizontal stretch or shrink that you would multiply by the reciprocal in your table if you were graphing it. This asks us to write the equation. So what you need to do when you write equations is you need to decide if it's better to use a sine function or a cosine function. And there isn't always like a right answer. It just is going to affect your final answer when you're done. With what we're doing today, I'm going to usually use cosine. But if I look here and here in this picture, or in this little blue one that I drew right here, if I look from the top point to the next top point, that looks like it could be a cosine. But if I look at it differently, and use a highlighter color. If I looked at it maybe from here to here, then that would be a sine function. It's still the same function, regardless. So it depends where you're kind of starting. For this one, I'm going to make it a sine function. So I'm going to say the distance, oopsies. The distance is equal to, now we need our amplitude. So you guys said that it could go up 10, it could go down 10. The amplitude would be the absolute value of that, which is 10. Oops, sorry, that's my amplitude, not my D. My amplitude. So I'm going to start with 10. Because I don't really have the entire situation for this graph, I do want to let you know that it could have been a positive or a negative 10 here. It depends, again, where I look at in the picture. If I looked at where I just drew my yellow, that would be a negative 10. But if I went back further and I looked at from here to here, that would be a positive 10. So it's going to really depend on your picture of what you're using. And I don't really have a picture for this first one, so I'm just letting you know it could be a positive or negative 10. It's not so important because this is just an example, but and we're going to have sine. Oh my gosh, I keep forgetting to switch it back. Then we're going to have sine, and then that omega value comes next, which is pi over 2, and then t. So that would be our equation. Again, the plus or minus, that just really depends on if it's going down first or coming up first. This also asks for the frequency. Oh my gosh. I'm having trouble like making it stay in one place. It also asks for the frequency. And in that table or this box up here, it says the frequency is omega divided by 2 pi. So if I take my pi over 2 and I divide it by 2 pi, it'd be the same thing as pi over 2, multiplying by 1 over 2 pi, and I get 1/4. And one thing you might notice is that the period and the frequency, or maybe you'll look at the actual formulas for the period and the frequency, and do you notice something about those equations? They're reciprocals of each other. Yep. Okay, so I'm going to skip this one because it doesn't have any, it's not a real life application. It's just like find the stuff I know you guys like, but I want to do one from your assignment. So what I'm doing right now is I'm going to Cami and I'm opening just a blank page, because for your assignment, if you haven't looked at it yet, there's no room for you to write on it. It like looks like this. There's no room for you to write on it. So you're going to want to do it on paper or on Cami anyway. I'm doing number 1 with you as far as I can get. So that number 1 really won't be part of your assignment. Unless I don't get done and then you have to watch the video to finish it, then you'll have to like add that in. But if you want to have your assignment on paper, but you do this one on Cami, that's totally fine. I'm just letting you know, because I went really fast in my other class and they were like, where are you writing this? I'm just writing it on a blank page. Okay? up for like not the whole time. The question is saying that we have this girl named Megan. Megan Go Round is her name. And she's riding a Ferris wheel. And her distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, her seat is at the position shown. So when the Ferris wheel starts, she's sitting there at that dot. Let t be the number of seconds that have elapsed since the Ferris wheel started. Megan finds that it takes 3 seconds to reach the top, which is 43 feet above the ground, and that the wheel makes a revolution every 8 seconds. The diameter of the wheel is 40 feet. We're going to sketch this graph, and we're going to answer what is the lowest Megan goes as the Ferris wheel turns, and why is this number greater than 0? I really think without a graph we can answer question B. I've seen a Ferris wheel before. Yeah, why is the lowest she rides, which is, if you can see where my cursor is right now, why is the lowest she rides bigger than 0? Because it's not going to touch the ground because you lose your feet, right? It's not going to hit the ground. So it'll start somewhat above it. Also, maybe more specifically, the highest point on this Ferris wheel is 43 feet above the ground, but the diameter of the Ferris wheel is 40 feet. So how far above the ground is she when she's at the very bottom? 3 feet. Okay, so knowing this information, we're going to sketch a graph. And this is sketching, it's rough. It's not going to be super accurate. So I'm going to have my time axis and my distance axis. I guess I don't need negative numbers. And some numbers that have been pointed out to us as I was reading is that at 3 seconds, again, this is time, at 3 seconds, it reaches its highest point at 43 feet off the ground. Ugh. And then it takes 8 full seconds to make one rotation. 8 seconds to make one rotation, which I think is kind of fast. So 3, we're going to add 8. 4, 5, 6, 7, 8, 9, 10, 11 would be adding 8 to 3. That is the second time she would be sitting all the way at the very top. So at how many seconds would she be at the very bottom? 7. And the very bottom, we already talked about, is 3 feet off the ground. Right in the middle of 3 and 7 would be our equilibrium area. And that is at what feet, the equilibrium? 5? Oh, 5 seconds. Oh, I said at what feet? You guys are 5, what? No. At 5 seconds, yes. At what feet? 23 feet, yeah. And then again at 9 seconds as well. So we've got a couple more points here. Okay, but this is not the entire graph. It is going to keep going. And also, this is 3 seconds. So it can go all the way to 0 seconds. This is like where she gets on. And I tell you what, my graph is not drawn to scale. So don't think that she got on at 25 feet or whatever, that was 26 feet. Because it's not drawn to scale. Okay, but the way that I set it up kind of makes me think like I should do a cosine. the way that I set it up, how I talked about the highest point, and then I did a full cycle from there. So I'm thinking I'm going to do a cosine. So we're going to start with d equals, and then I need my amplitude. So if 23 feet is the equilibrium, how far above and how far below is this going? 20. Is she going up first or down first? Well, if it only takes her 3 seconds to get to the top, but it takes a full rotation 8 seconds, she must be going the shorter distance to get up. She must not be going all the way backwards. She should be going straight up. Okay. 20 cosine. All right, what's our period? Louder. It is 8 seconds. A period would be how long, horizontally, how many seconds before for one full cycle, one full rotation of the Ferris wheel. So our amplitude is 20. Do we have a vertical shift? Do we have a vertical shift? Yes, because normally the 23 would be a 0. So it'll be 23. Up 23. Do we have a phase shift? Why isn't it what? Why isn't it what? Do we have a phase shift? Like normally cosine starts at like 1 and 0. It shifted up. It had an amplitude. But I'm only asking about how far over is it starting? A little bit louder, I couldn't hear you guys. Oh, 3. Which direction 3? Right 3? Maybe that's what you said. That's what I had trouble understanding. Okay, so when I put this stuff in, if I know my period, the number that actually goes in is not my period. The number that goes in is 8. So FYI, if you have to leave, I'm going to continue making a video till I'm done with this, even if it's after school. So this video will be done. So if you're leaving with the athletes, just be quiet on your way out. Thank you so much. The assignment is posted. You'll probably have some questions. But I'm going to finish recording this one. Okay, so we have to do 8 equals 2 pi over the omega to find this omega value. So omega is going to be 2 pi over 8, just pi over 4. Nope. So I'm going to put that omega value here. And then we have our x. Since we're going to the right 3, I will minus 3 and then up 23. So that is the equation. The second part, I'm going to use the calculator for. So the first thing that you want to do when you get to the second part is done before. You're going to type that cosine in. You're going to type that function calculator. The second part of the equation, or I'm sorry, the second part of the question says predict her height. I'm going to use the vars. and I'm going to go get y1. And my first at time 6, at 6, what is the distance? Actually, it's part C. So when time is 6, we get the distance is approximately 8.8579. And that's for like the first part. The second one says when time is, it says 4 1/3. I'm going to write it as 13/3. So all I'm going to do for that is I'm just going to get that exact same equation again and type 13/3 instead. And the answer is 33. So at 13/3 seconds, at 4, she is 33 feet above the ground. And then the third one says 9. So I'm just going to use my calculator again. And second enter. I'm going to change this to a 9. And now it's 23 feet. And the last one is that time is on. It's asking what point or what height she's getting on the .8579. Do you have any questions on that part? We've done that before. If you need to go, you can go. I'm just going to continue recording the video. Like, I have a full class here. So you guys have a video. Bye, have a great day. If you want to stay, you're more than welcome. Bye. So then the question at the end says, what is the value of t the second time she is 18 feet above the ground? And we have done this before as well. We're going to put in 18 for the d. And so I've got, let me zoom out just a teeny bit so I can see it at the same time. So I've got 18 equals 20 cosine pi over 4 x minus 3 plus 23. And we have to solve for x, and we've done this before. I'm going to take away 23. I'm going to get negative 5. I'm going to divide by 20, negative 1/4. And then I have to do inverse cosine. When we do that, it could go around multiple times. So we're going to have a plus and a minus in front of the cosine. And we're also going to have that 2k pi. Remember doing that before? So on the other side, we've got pi over 4, and then the x minus 3. So I'm going to multiply both sides by 4 over pi. Bye. And then add that 3. I'm just going to add that 3 in this step here. And once you have x by itself, we can use our calculator. And I'm just going to type in that 3 minus 4 cosine inverse negative 1/4 over pi first, and then the second I'll do 3 plus that amount. Oop, I have my 3 in the wrong spot though. And then after that, then we'll see if we need to add on an 8K or not. Let me use my calculator. I'm going to type that in. So 3 minus inverse negative 1/4 over pi, and I'll do the same thing with plus. Where was I? So I get my first 2 x's would be 0.678 and then 5.322 maybe. And those are my first 2 x's. This says what is the second, look on here. It says what is the second time she is 18 feet above the ground. So this would be my first 2 x's. The second time would be this answer right now, there. So what would be best for your assignment? It's not going to be checked yet. By next class, it's not going to be checked yet. But what would be best for your assignment is that you find the equation for each. If you get the equation wrong, you're going to get everything else wrong. So if you find the equation first, we can check that in class next time, and then you can go answer the rest of it. So finding the equation is probably the most important part for next class.